Welcome everybody to our first Ask an Expert virtual event. We started these events to create opportunities for folks to connect with and learn from the myriad experts who have worked in the Grand Staircase Escalante region and have expanded our understanding of GSE&M landscapes and ecosystems. If you're new to Grand Staircase Escalante Partners, we are a nonprofit organization committed to supporting and promoting Grand Staircase Escalante National Monument. And we share monument science through educational programs. We carry out restoration and monitoring projects. And we advocate for land management policies that support the biodiversity of this region. In slight contrast to our community lecture series, our Ask an Expert events are meant to be a more informal Q&A with our conversation following the direction of our audience questions. Before we dive into this conversation with Dr. Mike Scott, though, I'd like to give you a quick overview of participating in a Zoom webinar, in case you haven't done this yet. Since this is in the webinar format, everyone except myself and Mike here are muted and not shown on the screen. So if you need to get up and stretch, have a quick conversation with your dog, anything like that, don't worry, we won't know. So real quick, so to ask a question, there are two ways that you can do this. One is using the Q&A box. So this box is located at the bottom menu, on the bottom of your screen. Depending on which version of Zoom you have, you may need to mouse over the bottom of the screen for that menu to pop up. So you can click on the Q&A icon, type in your question, and hit send. And then those questions can be either answered by typing or it's something that we'll answer live. So for this event, any of the questions that are topical about river ecosystems and restoration, we'll answer live. If you have any logistical issues or logistical questions, feel free to drop them into that box. And if it's something that everyone needs help with, we'll answer it live. If it's a personal thing to figure out, we'll help you out by answering, giving you a typed answer in the box. You can also ask a question verbally. So if you want to speak your question out loud, you can use the raise your hand function. So you click on the raise your hand icon, that's going to communicate to me that your hand is raised, brings you right back to 5th grade. When I've come to your place in line, I will let you know, unmute you, and then you'll actually get this little sign saying the host would like you to unmute your microphone, and you can either choose to unmute yourself and ask the question, or if for some reason you're no longer interested in asking the question, or it's not a moment where you can unmute your microphone, you can choose to stay muted. Then after you ask your question, I'll re-mute you just to make sure that we're keeping the background noise down. So, okay, so next we have a hand raised. Here we go. Hold on one moment. All right, I'm gonna allow you to talk here. Sorry, Veronica?
Yes, hi.
Hello.
Hi there.
You have a question, or are you just practicing raising your hand?
No, I have a question.
Okay.
Who on this screen knows what the latest information is about returning cattle to the main stem of the Escalante?
All right, so we're diving right in.
Yep.
Mike, would you like to answer that question and then circle back to a little background information, or provide some background information and then answer that as our first question?
Sure, I can answer that. But let me just ask Veronica. So, could you kind of restate what your question was again about cattle?
Well, I know that the allotment was bought out years ago, and I understand that the BLM is intending to return cattle. I don't know whether they've already sold it to another rancher or what, but you know, there have been thousands of volunteer hours and millions of dollars spent on restoring that riparian area, and I just want to know what the current status of the BLM's intentions.
Yeah, I actually don't know the current status of that particular situation. The last I heard was that the reintroduction of cattle was off the table at this point. As you say, you know, there have been cattle along the Escalante in the past. The Park Service in the Glen Canyon portion of the Escalante excluded cattle first, and then that was followed by exclusion in the BLM portion. And I don't have the exact dates, but the cattle were excluded sometime in the early 90s from both Park Service and BLM reaches of the Escalante. But again, I don't know. The last I heard was that the reintroduction at this point is off the table. But I don't know that I have the latest word on it.
And it looks like Lisa actually just added a link. So if you you also have an option to open up the chat. And I know that there are actually a lot of experts here in our audience. So it looks like Lisa provided check with Mike P at the Trust and a link for us to check out at another time. So
Great.
Thank you. And then Mike, would you like to circle back so for folks who don't know Mike before, today we're fortunate to be joined by Dr. Mike Scott to discuss riparian ecosystems and restoration. Mike has spent 26 years working with USGS, and for the past 10 years was an adjunct associate professor at Utah State, and is now a faculty affiliate with Colorado State University. And Mike, can you tell us a little bit more about your background and how you came to be involved in work in the Grand Staircase Escalante region?
Sure. So I got my degrees in riparian ecology. Riparian basically meaning streamside ecosystems, and my particular interest and area of expertise was woody vegetation, particularly cottonwoods, which are the dominant tree along rivers in the western U.S. And I'm just interested in the processes, the physical and the biological processes that create and structure streamside vegetation along our western rivers. And this vegetation in particular is important for numerable wildlife species, terrestrial wildlife species, as well as aquatic species, which depend on streamside vegetation for inputs of organic matter, shade, that sort of thing. So these rivers and their adjacent vegetation are very important and tightly linked ecological systems. And I early on, as in my 20s, I developed a real keen interest in the red rock country of of Utah, and I've been enchanted ever since. And I think I did my first hike in the Escalante back in the mid-'70s, and yeah, drove through Escalante in the mid-'70s, and it was a little bit different than back then than it was now. And I don't know, I guess I'd have to say my impression back then was, wow, Escalante's been practicing social distancing for a long time. But it was a charming little town back then, and there was an old abandoned house that I considered even putting in a bid for, but unfortunately I didn't. Anyway, I got involved about 10 years ago with the Escalante River Watershed Partnership, and the Russian olive removal project along the river, and at that time started a study to investigate the origin, the basis for the invasion of Russian olive along the river, try and understand what factors were involved in the rapid establishment of Russian olive along the Escalante, how that changed the river compared to the pre-invasion condition, and then what, now that Russian olive has been removed essentially from the main stem, what the prospects for the recovery of the river to pre-invasion conditions are. And so, yeah, that's my background, with brief background with Grand Staircase, Escalante, and Glen Canyon, and the Escalante River in particular. Are you muted, Nuke? Are you muted, Nuke?
Thank you. Thank you, Mike.
Yeah.
Thank you for that introduction. And now we're going to open it up to questions. So the first raised hand I see is Sarah. And ask your question.
Hi, can you hear me?
Yes.
Hi, Sarah.
Hi there. Hey, so I have a question, and this is related to my recent learning about all the different bat species that live within the monument, and in particular that are inhabiting the riparian areas. And so my question is, in terms of restoration work, how do we ensure that those habitats are protected, where the bats are living? Like, what's sort of the process related to that in terms of inventorying different species that are dependent on the riparian areas, and making sure that they're taken care of when, I guess, like pre and post restoration efforts?
Right. Well, depending on the species of bat, a lot of the bats that occur along the riparian area are probably roosting in along canyon walls, in niches in the canyons. In particular, there are some species of bats that actually roost in trees, but I don't know if those particular species are found along the Escalante. The Escalante River and the riparian habitat are going to be critical for bats because that's a perennial source of water for bats in that arid region. And also the bats are, many of the bats are insectivores. Most of the bats are, probably are insectivores, and so they're feeding on insects that are also critically dependent on the aquatic environment. So I would say that, as long as the the channel processes, natural channel processes are occurring along the Escalante, providing, pools and riffles and habitat for aquatic insects, then I think we're probably doing a pretty good job of taking care of the bats. I don't know, for example, if the bats are selectively feeding on any particular species of insects that are found only on certain native or non-native tree species, say like Russian olive or tamarisk, but I don't think that.
Yeah, I was curious about that, like if maybe they were also utilizing some of the invasive species, but it makes more sense that they're inhabiting the canyon wall areas, most likely.
Right. Yeah. I mean, I think the importance of the structure and the composition of the woody vegetation along the stream is going to be far more consequential to the birds than they are in the bats per se. So I mean, I think the bats are probably going to be pretty good.
As long as they have their insects.
Right. Yes.
Right. Gotcha. Okay. Thank you.
All right. All right. So our next question is from Ken. Can you briefly explain why Russian olive hurts the ecosystem and why it needs to be removed?
Right. That's a great question. So Russian olive was, we know that Russian olive from personal reports of lifelong residents in the towns of Boulder and Escalante, we know that both the state and federal governments made Russian olive available for planting in the towns of Escalante and Boulder. And they were planted in those towns in the watershed back in the early 50s. The oldest Russian olive that we were able to find dated to 1951. They were planted in the community. It wasn't appreciated at the time that Russian olive was invasive, and soon, because of through dispersal by birds and even dispersal by water, through irrigation return canals and along LV Wash and along the main stem Escalante, the Russian olive started establishing in scattered individuals along the river, starting in about the mid 1960s, and then they remained relatively scattered and fairly not even that noticeable until about 1980 in the upper reach, when, and that upper reach would say be by the Highway 12 bridge crossing. They started to establish rapidly in very large numbers, and most of the establishment from 1980 on, and it progressed downstream through over about the next 15 years. And what happened is, as those Russian olives established in very dense bands along the edge of the stream, they began trapping sediment and build levees, which narrowed the channel dramatically and prevented the channel from moving or eroding, which is necessary for native cottonwoods and willows and other native riparian species to establish. So what the Russian olive establishment did was it narrowed the channel, prevented native species from establishing, because it prevented the channel movement, it also simplified the shape of the channel and made the channel in many places look more like an irrigation ditch than an actual river channel. the consequences of that is that it's simplified the aquatic habitat as well. And although there haven't been any studies to examine that in particular, it is probably likely that it altered the ecology of the aquatic system and may have altered the productivity and the diversity of insects that were being produced and emerging from the stream, which again are important for bats and birds and other species. Beyond the sort of some of those biological examples of negative effects of Russian olive, it suddenly became very difficult for people to walk or boat along the Escalante River channel as they had in the past because of this extreme narrowing and levee building. So there were recreational impacts as well, and a number of the local outfitters started complaining very early on about the proliferation of Russian olive along the river. And, early efforts, Bill Wolverton and some other people with the Park Service started doing some control efforts with Russian olive, but it wasn't until 2010 that a large sort of multi-agency effort was established to go in and control Russian olive along the entire reach of the Escalante River. So those are some of the negative aspects, but I'll also say that not even an invasive species is not necessarily purely detrimental. There may be some positive benefits for certain bird species with the existence of Russian olive, but certainly Russian olive didn't evolve with the system, and so removing Russian olive now probably is not going to cause any deeply negative ecological effects on the system as a whole.
Great, and then we have just a follow-up question from Mallory saying, I think I missed if Russian olive was planted purposefully next to streams or was in yards as ornamentals and expanded to the stream sides.
Right, yeah, good question. The evidence is that it was planted in yards. Some of the early reasons for planting Russian olive, and it was planted extensively in Utah, in the cities in particular, and throughout the West, is that it's quite tolerant of dry condition, drought. It grows rather well in dry conditions, so it was a good choice for a yard ornament. It made nice shade, and actually introduced pheasants, particularly like Russian olive, because Russian olive and pheasants evolved together in Eurasia. So early on, before the invasive nature of Russian olive was fully appreciated, it was thought by some conservation agencies that it was a good idea to plant Russian olive, and it seemed like a fairly good choice at the time. But then birds would then feed on the Russian olive seeds and then fly to various locations. They would pass the seeds, and then the seeds, if they fell in favorable locations, would then sprout, grow, and then produce more seed. So originally they were planted mostly in yards, maybe along irrigation ditches, but then the seeds found their way to the river corridor.
Great. So our next question from Stephen is, what is the status of beaver in the Escalante River Watershed, and what is their role in current or planned restoration projects?
So I don't know of any plans to introduce beaver currently. I know that there was talk early on of reintroducing beaver in the headwaters. There were on some private properties some efforts to reintroduce beaver. But I know that there was locally some real opposition to beaver because of the potential for beaver to clog irrigation ditches, things like that. All of the I know early suggested discussion of reintroducing beaver had to do with the headwaters, mostly on Forest Service land up on Boulder Mountain. I don't know that there were any discussions of introducing beaver lower down in the watershed.
All right, and Steve asks, have the tamarisk eating beetles been released in the Escalante region? And maybe you can share a little bit about what the tamarisk eating beetles are for our audience members who maybe aren't aware of that.
Right. So, well, let me answer. Let's see. So I'll answer the specific question about tamarisk along the Escalante and the presence of the beetle. For various reasons, probably most importantly, because the Escalante still has a relatively natural flow regime, and it has a fairly, it has one off-channel dam above the town of Escalante, but in general, the flows on the Escalante, particularly the flood flows, the snowmelt floods in the spring, and then the monsoonal floods that occur during monsoon season are still relatively natural. As a result of that, tamarisk was never that important or widespread along the Escalante, except way down near where the Escalante enters Lake Powell. So in the middle and upper reaches, tamarisk was not ever really considered to be much of a problem. For the few tamarisk patches that I have seen along the Escalante, I've not seen any beetles per se on those plants, but they very well could be there because they're so the beetle is so widely spread now throughout the Colorado River basin. The beetle that we're talking about was purposefully vetted, searched for and vetted by USDA over a period of about 15 years. And a researcher went to Asia and found a number of beetles that fed only specifically on tamarisk. And they're a leaf beetle, and they the larvae and the adults will feed on the tamarisk, and they'll defoliate the tamarisk. And in some situations, they'll actually kill the tamarisk. But before the tamarisk, because there has been such a long and sort of disastrous history of introducing non-native species, including insect species, into the U.S., the USDA spent a very long time to make sure that this beetle would not switch hosts if it ran out of tamarisk to eat. That is, that suddenly if it did such a good job of defoliating tamarisk that it might just decide, well, gosh, I'm hungry, I'm going to switch over and start defoliating native sandbar willows. Well, it was pretty well established that the tamarisk beetle only feeds on tamarisk. And when the tamarisk is done, the beetle populations basically crash. But beetles, those beetles have been now introduced legally and illegally throughout the western U.S. now, and are very widespread. They're very widespread in the Moab area. They're completely dispersed throughout Grand Canyon, and regularly are defoliating patches of tamarisk in the Grand Canyon. But as far as tamarisk in the Escalante, I'm not really sure. Tamarisk beetle in the Escalante, I'm not really sure. But again, tamarisk is so relatively rare along the Escalante River that it's not really much of an issue for the Escalante River watershed.
Okay, and we have a little bit of a follow-up question about the tamarisk beetle. So you told us a little bit about what happens when there isn't tamarisk left to eat. But assuming there is tamarisk, we have a question from Ronnie. Has the tamarisk beetle become naturalized? And I guess that would expand to, are there settings where you know it's become a naturalized population?
So by naturalized, I guess I'm assuming that you're wondering if that they're persisting through time, they're successfully reproducing, they're surviving winters. Yes, they are. Again, but they are again only specifically feeding on tamarisk. In some places, it's been documented now that they've actually killed, because of repeated defoliation, killed particularly older and moisture-stressed tamarisk plants. So the beetles are naturalized in the sense that they are surviving year to year. They're reproducing successfully. They're successfully invading new patches of tamarisk and defoliating them. And in areas where the tamarisk has died and is no longer existing in as large numbers, the beetles are fading away. So that seems to be one of the very a few shining successful examples of successful biocontrol on a troublesome species like tamarisk.
All right, thank you. Our next question is from Sarah, and she asked, how can we use the riparian areas along the Escalante to better understand and respond to climate change?
Oh, well, that's a really good question. Yeah, well, that's a great question, particularly from the point of view of the sort of the long-term history of the Escalante River and a lot of the regional rivers in the southwestern U.S. Because the Escalante and many of the other regional rivers, the Paria, the Little Colorado, some of these other rivers, they have a long history of what's called Arroyo cut-fill cycles. And what happens over time, and these cut-fill cycles along these rivers are basically under the control of climate. So the Escalante River, for example, has about a 6,000-year history of cutting a deep arroyo, evacuating all the sediments along the river-deposited sediments along the river channel, and then over hundreds of years, even 1,000 years, the valley fills back up with sediments, and then at some point large floods will cut a deep arroyo, a steep-sided channel into the alluvial fills. That channel will widen. The sediment is moved out again, and then it starts filling again. So it's like cut, fill, cut, fill. The Escalante is over 6,000 years has cut and filled at least 4 times that we know of. And these are all in relation to, and these are all under the control of climate. During cooler, wetter periods like the Little Ice Age, the valleys fill very slowly with sediments. And then during periods where it's drier and that feature and will sometimes feature large flood events like happened at the turn of the century along the Escalante and a lot of the other regional rivers, then that sediment is evacuated out and the cycle starts all over again. So the valley of the Escalante, the last big incision occurred along the Escalante with a big flood starting in 1909 along the Escalante, ending with a flood in 1932, which then produced a huge arroyo on the Escalante. The valley's been filling ever since about 1940 and will continue to fill. Now, the big question is, going forward with climate change, is will the valley continue to fill, or will we see periods of incision because the climate is predicted to get warmer, certainly, and it's unclear, but some projections are suggesting it's going to get drier as well. So we're sort of entering a sort of an unknown, really, and what happens to the Escalante is going to be very telling going forward. If it gets warmer and drier, we have more large sort of catastrophic floods like we had at the turn of the century. The riparian area along the Escalante may look very sparse and dry compared to how it looks now, for example. So riparian areas in the southwestern US are going to be very critical for tracking and looking at the effects of climate change. They're going to be very sensitive indicators of climate warming and in particular climate drying.
Fascinating. Sort of on that thread, what are some of the metrics that you use to measure riparian health? And maybe could you share a little bit about tools that you use to monitor these landscapes?
Right, that's a good question. Well, there are a number of metrics that we sort of currently use. We look at the density of native riparian species, the cover. You could measure that both on the ground. You could also use now the very good high resolution aerial imagery, which in Utah is available on a annual basis now. So you could use both on the ground and aerial imagery to monitor the extent of the band of riparian vegetation that's growing along the river. That's going to reflect the extent to which the channel is moving naturally in response to flood events, sort of eroding and depositing, which is a very important process for rivers and associated riparian vegetation. And then the amount of water that flows down the Escalante annually. The riparian vegetation is critically dependent on the water supplied that flows down the river. So the extent of the riparian vegetation reflects the amount of moisture available along the Escalante River corridor. If that ribbon of riparian vegetation shrinks or expands, we have a pretty good idea of the moisture conditions, the midterm moisture conditions along the Escalante River. Also, the extent to which the Escalante is operating naturally is a fairly good reflection, is fairly well reflected in the diversity and extent of natural vegetation. And oftentimes systems that are perturbed either by large natural disturbance events or by human activities, those systems, riparian systems, tend to have larger numbers of non-native plant species. So looking at the ratio of native to non-native plant species is also a good metric for assessing the relative health of the riparian vegetation, the riparian ecosystem. And then also there are now efforts underway to look at satellite imagery and use satellite imagery to look at the reflectance of the vegetation, and from that determine if the vegetation is water stressed. So there are lots of really new and interesting remotely sensed ways of gauging the health of the riparian vegetation as well.
Thank you. That's so cool to hear about all the different technologies we have to examine this. So we have several follow-up questions that relate both to that question and the one before. So Stephen asks, what are the ecosystem effects of channel incision? And based on your last explanation, I think we can see a rise in non-native species, but can you say more? Are there additional ecosystem effects from those cut fill cycles?
Right. Okay. So yeah. So there's a couple sort of things going on there. The channel incision. So there was the channel incision that took place as a result of the natural processes that occurred in the basin that have occurred naturally over thousands of years. Basically, the channel incision, that incision process resulting from a series of large floods, basically transformed the Escalante. We have some photos from the turn of the century prior to 1909 that show that big stretches of the Escalante River were actually wetland marsh. The Escalante River, I have photos of this. I can share these photos. We could, if we want to post these later on, mm-hmm. I can actually post a PowerPoint presentation that I gave on this topic. But you can see that the Escalante back before 1909 was basically a wetland marsh with a very narrow little channel and only a few cottonwoods out along the edge. This marsh was, the valley was full of sediment. This marsh was just perfect for when the settlers first arrived. I mean, it was just, the perfect place to graze cattle. There was just forage everywhere. The 1909 flood cut a deep channel. It drained the floodplain, eliminated the marsh, and then the subsequent floods through 1932 basically reset the entire Escalante River ecosystem. You basically had a big, broad, sandy channel with only a few scattered old cottonwoods on the original floodplain that hadn't been eroded away. And then starting with regional channel narrowing as a result of a dry period starting in the 1940s, that big, wide, braided, sandy channel started to narrow, and cottonwoods and willows established on that old original active channel started narrowing the channel naturally. Then Russian olive came in and narrowed the channel in an extreme way by producing levees, which that had a very negative effect on the channel, in that it simplified the in-channel habitat and made the river channel look much like an irrigation ditch, which aren't particularly known as being hotspots for biodiversity. So by removing the Russian olive, the channel is now, hopefully, is in places starting to move a little bit and starting to develop a more diverse in-channel habitat. So I'm trying to answer the question that way because I'm not sure if the question was directed at the original sort of the cut-fill cycles or the narrowing of the channel that was caused by the Russian olive. The cut-fill cycles are part of a very long-term natural process that has been going on for, several thousand years. And each of these stages will last perhaps hundreds of years. But, the Escalante in 1907 looked nothing like it did in 1932. And the channel in 1932 looks nothing like it did in 1980 before the Russian olive invasion. And then after the Russian olive invasion, it looked even different than it did in 1980. So these rivers, particularly these Arroyo cut-fill rivers, go through these long cycles and have very different states. And they function and look and have very different ecological attributes in each one of these different stages. So, yeah. So anyway, the intervention to remove Russian olive was relatively minor if you think of the long-term history of the natural cut-fill cycle along the Escalante River. And I think the objective of that removal was to restore the river to the pre-invasion conditions, which featured a wider, more braided, more actively cutting and filling channel. So I hope I addressed that question. If not, hit me again.
Great. And just as a time check, we have about 10 minutes left, so we'll definitely answer the questions that have come in thus far. If you have any remaining burning questions, you are welcome to still put them in through the Q&A, and we might have a chance to get to them. One quick follow-up about the cut-fill cycles. We had a question: does livestock grazing have an effect on cut-fill cycles?
That's a great question, and that has been a burning issue with geomorphologists for several decades. Certainly, the introduction of cattle prior to around the turn of the centuries, the Escalante was settled in around the 1870s. Certainly grazing that was occurring on the floodplain, trailing by cattle, browsing of upland vegetation, browsing, grazing on the floodplain proper certainly would have had an effect, perhaps on the timing, the particular timing of the incision along the Escalante. But after decades of arguing and studying and looking at numerous case studies, geomorphologists have pretty much all agreed that these cut-fill cycles are primarily under the control of climate. They are driven by climate. Does grazing influence perhaps the timing and the extent of the initial cutting and widening? Yeah, probably, undoubtedly, but it's not a primary factor. Climate is the primary factor. So the question is, and again, the answer to that, and the evidence for that is the Escalante, the last cut cycle on the Escalante occurred after grazing had been introduced prior to the turn of the century. But there were at least four other cut-fill cycles four other cut cycles that were initiated well before cattle appeared on the scene. So it's pretty obvious that these were being driven by shifts in climate.
Great. So we have a question. Please explain what may cause lowering of groundwater levels, and can you talk about cottonwood response to declining groundwater levels? Right.
Another great question. Cottonwoods, other riparian species are critically dependent on the groundwater under the floodplain of a river like the Escalante. Again, when the river at the turn of the century cut that channel deeper into the floodplain, in some places in the upper Escalante, the channel cut 20, 30 feet down into the valley fill. That immediately caused the groundwater in the adjacent floodplain to drain into the channel and flow out, lowered the groundwater. We've done studies showing that, we've had in places where they went in and done sand mining, dropped the water table about 3 meters under a stand of cottonwoods. Within about 3 years, the cottonwoods didn't die immediately, but within 3 years, about 80% of the cottonwoods died as a result of the permanent decline in the groundwater. But again, not all of them will die because of say, sometimes you'll have little clay lenses that were developed in the floodplain, and those can perch water, and cottonwoods in certain situations can survive groundwater drawdown. But for the most part, the majority of cottonwoods in a stand along a river will die if you drop the water table far enough, fast enough.
All right. We have a question from John. As you remove invasive species like Russian olive, how long does it take for native species to return?
Well, in the case of Russian olive removal, the Russian olive established in the presence of native species. So what it did was it basically established on unvegetated sandbars streamward of the existing cottonwoods and willows. So for the most part, along the Escalante, the removal of Russian olive just simply created more space, and there's still lots of native vegetation that exist along the Escalante. One of the follow-up concerns on the Escalante is, will Russian olive reinvade some of these moist bars that they originally established on? when the invasion process began, or will some other non-native species occupy the sites that Russian olive was removed from? But the hope is that with the Russian olive removed, that the river is going to be able to start moving the channel again a little more naturally, which will then create fresh deposits of sediment, which the native species like cottonwood and willow need to reestablish. So hopefully what will come of the Russian olive removal is that you'll get a little wider channel, you'll get some more sandbars, and you'll get the native species establishing a little more extensively now than they were prior to the removal of Russian olive.
Great, thank you. We have a question from Jonathan. Aside from historical imagery, what methods were used to determine the different cycles the river experienced over the last 6,000 years?
Right, that's a great question. So all those cut-fill cycles were based on excavations. So when the last cut cycle occurred, it cut through old channels, and so it exposed old channels, and then the sediments exposed in the walls of the most recent Arroyo were dated using various techniques, and so the sediments were and then you could see old channels in the cut banks of the Arroyo, and so the researchers would go in and age the sediments, like with carbon-14 dating and other techniques now that allow dating of like sand particles and things like that. So they were able to reconstruct the ages of old channels and the timing of when those were cut, and then also how long it took for the sediment to accumulate in the former channels that had refilled. And then also they went into old caves and found old flood deposits, and then they were able to age calculate the discharge associated with old historical floods that have occurred over the last several thousand years.
Wow, that's really cool. It's been really exciting to hear all about these various topics, and Lisa has asked a great question, I think, to close out on. So Lisa's question is, we've talked about a variety of threats to riparian areas. What are the top 3 biggest threats to this area? What can we do? And what does your ideal riparian area across southern Utah look like?
Ooh, now what was that last one? What is the
what is your ideal riparian area in southern Utah look like?
Okay. Threats. So I would say the threats that come to mind are both, all right, I'd say that the largest threat to the integrity of existing riparian ecosystems in southern Utah, and I would say actually worldwide, is just climate warming, and then sort of the big unknown about whether we're going to get the same amount of rain or less rain, more moisture or less moisture, but regardless, that even if we get the same amount of moisture or even a little bit more, if it gets warmer, effectively we're going to have less moisture. So these riparian systems are critically dependent on water. So the biggest threat to these systems come from water availability in the future. And there are a number of ways in which, water to riparian systems are going to become limited by, let's say, through climate warming. There'll be less runoff. There'll also be, as a result of that, there'll be more human demand for water. So then people will be wanting to use that water, which would have otherwise flown through riparian systems for human use. And yeah, right. And it's sort of complicated. What are the other threats? Yeah, I would just say, well, various kinds of multiple kinds of developments that will limit water to riparian systems. And so there are multiple threats related to water availability, including human-related climate change, water diversion, water development, groundwater pumping, that sort of thing. Things like, and then other factors then become, even more important and critical. I think that then if you're starting to graze, riparian areas that are increasingly water limited, then you're going to have greater and greater impacts from grazing. Anything that you would do in the riparian area, in a riparian zone with increasing water limitations is going to cause more and more stress. So that to me is the fundamental. So yeah, the three threats to me are, it's like water limitation, water limitation, water limitation. The ideal riparian system, in southern Utah, a little bit dependent on sort of the river structure, the channel structure, but I would say, these rivers, when the valleys were filling, you had, water flowing down a channel. You had channels that were cutting, eroding and depositing. There was enough, with water availability, you have sort of a intermixture of herbaceous vegetation, unvegetated patches, water, bare sediments, and woody riparian vegetation. Those are elements of a good, healthy riparian ecosystem in southern Utah.
Great. Thank you so much. Well, thank you everybody for joining us this evening, and thank you, Mike, for taking the time and sharing your knowledge with us. So if you want to return to all these topics again, this video will be available as a recording within the next week or so. And I'll tap on the images that Mike said he would share with us so that we can sort of see some of the things that he was talking about.
Like a PowerPoint, I can just send.
That would be great.
Stuff and then if somebody has you can share my email if somebody has something that they wanted to follow up with me. I'd open to responding by email to some of these things. So
great. Thanks so much for sharing your expertise. Take care, everybody, and we hope to see you at our next event.